Dr. Randy Rarig is a worldwide physical analysis advisor for CATGen Corporation. He received his Ph.D. in organic chemistry with a focus on single crystal X-ray diffraction of organically templated mixed metal oxides from Syracuse University. Was it close?
Yeah.
So before joining CATGen, Randy worked as an analytical chemist for Wyeth Pharmaceuticals, now Pfizer, and as an application scientist for XRF at Malvern Panalytical. Dr. Rarig is responsible for all physical analysis tests and instruments for catalyst testing, as well as for all stages of crude oil in the refining process. So with all that, we're gonna hook the mic, and it's all yours, Randy.
All right, thanks, Sergey. I didn't see Jesus' presentation until just now, but it actually fits right in. So he gave you a lot of theory and a lot of stuff on the nebulizers. I'm going to start showing you some real world examples of this stuff as soon as my computer wants to start working. Just a quick background about us, CATGen itself. We're formerly Albemarle Catalyst Corporation. They spun us off about 2 years ago, so we're now a standalone entity for them. But we serve global refining customers worldwide. We do FCC, which is fluid catalyst cracking, so that's a lot of the refineries that are around here. We also do the clean fuel technology, which is the hydroprocessing catalyst, and then we have a performance catalyst division as well. A quick history, way back in the 1800s, CATGen was established as a sulfuric acid company, and it went into refining, and then it went into FCC in Europe at right around 1950. Ethel Corporation started over in Pasadena. Eventually, we all merged into Albemarle, and then in 2023, they spun us off and renamed us as CATGen to basically go back to our historical name. At our site, we are the analytical research and quality division. So we test all of our raw materials, intermediates, final products for FCC and HPC catalysts. We also support all of our refining customers. If they take our catalyst, even if they don't sometimes, we still do a lot of testing for them as well. We probably, in our department, run about 300,000 tests or more a year on those samples. So, as Jesus said, we do a lot of oil testing, so I'll get into that pretty heavy. And this is going to be on our OES system, which I have pictures of here later. But the problem is these samples tend to have a lot of small particles in them. They've got a lot of the catalyst fines in them, and we don't digest, so we do not get rid of these. So I'm short. So here you have, back that up a little bit. This is some of our dirtier sample. You can see, like Jesus said, it is very viscous. It's not a lot of fun to work with. We've also got samples that look like this. This is some of the aliphatic materials that we have. It looks great. It's really clean, kind of like the Vaseline that you can buy at the store. The problem with this stuff is it really likes to solidify out when it gets to room temperature or colder. So how do we prepare these? So we have to heat it up. We make sure that we get as homogeneous of a solution as we can with this. We then dilute it in an organic solvent. We mix them together, and then we run them on our ICP-OES. We do preparation by mass, and in our dilution factors are all done by mass. We have this prep mass system that does this for us. This has been a game changer for us. It went from 4 hours in the fume hood, diluting these down, to put them on the instrument, let it do all the work for you, and we can walk away from it. It has really been nice. But you can see all of our samples go into the heat block. They get heated up and then diluted into our organic solvent. Then we run, funny enough, we have the AJ systems as well, so nice little plug for them as well. We have an auto sampler that does all of our runs for us. We probably run anywhere from 30 to 60 samples a week. We try and batch them for obvious reasons, because it takes a long time to get all this stuff prepped. And as you can see, it runs up through to make the nice bullet that Jesus was talking about, so we know that we have good material running into our plasma. So the problems, right? What are some of the problems we run into? They have fines in them, and we don't filter, we don't digest, so we have those particles in our material. Our auto sampler does have a filter on it when it sucks it up, but these things are very, very small. They tend to get through. So that will cause us some issues on our nebulizer. Our RSDs start going up. That's one of the things we see. Our intensities go crazy. We have high, then we have low. Our internal standard goes to 75%, goes to 130%, whatever it might be. And then we have our problem elements. Sodium, silica, arsenic, and copper are the worst ones for us on this. And we also use a cooled spray chamber on that. So that goes back to that aliphatic one. The one that looks like Vaseline tends to crystallize back out in that nebulizer. So how did we solve this? Like Sergey said, last year I was sitting out there, was listening to these talks, and they were talking about, we have these OptiMist nebulizers in, we don't take them out, we don't change them, we don't clean them. All right. So I had a nice talk with Sergey afterwards. We ended up buying a couple of these, and we have them on our system right now. So right now we do have this, the OptiMist XL, which is their glass dual channel nebulizer, and we also have the Extreme. And we usually put one in and let it run. Right now we have the glass in, but we also have this one, which is the peak version of it, and we'll put that one in as well. We don't run any acid through this, so we don't really need the HF resistance, but we use both of them interchangeably. As you can see, this is the peak nebulizer that we have. This one has been our workhorse lately, and you can see how dirty it is. Like that oil does get in there and coat it and make it look really bad, but it's still running. It is still in our spray chamber, and it's working great at the moment. So what have these done for us? We have no more clogging, right? Our elements are all passing. Our sample that we run to check our recovery is coming out at less than 10%, and we're not touching this anymore. We have no carbon buildup. We don't run with oxygen, so we're running straight organics without oxygen, and we have no carbon buildup on our injector, and we no longer have to restart our runs, which we were doing a lot of, whether it was becoming clogged and starting to make carbon, if our elements were failing, trying to do our calibration standard, whatever it was, we're not doing that anymore. So we're having a very reliable run, sample after sample, week after week, without really tearing this apart. We do tear apart our spray chamber and clean it, but we don't really touch that nebulizer anymore. Moving on to our MS system, which we also have another AJ system as well. We have this is our HPC material, and we grind it up, and this one we do digest. And you wouldn't think, it doesn't seem like this would be a very high TDS or cause many problems, but it looks great, super clear, looks like it would run just fine. It doesn't. And it's funny, I was talking to one of the AJ guys this morning who has a customer running an analysis very similar to this, and they're having the exact same problem that we were. So they need to come and talk to Sergey, apparently. So our problem, we would be running, and we have 4, 5, 6 samples in, and all of a sudden we would start noticing that our liquid was running backwards. So we'd stop, we'd change tubing. I made AJ give me a new peristaltic pump one time, thinking that was the problem. Never thought about blaming the nebulizer. This stuff just looked too clean. So we always had to restart this analysis, whether we were on sample 1 or sample 10, which is the worst one, because then we have to start the analysis all over again once we clean. But we would notice it right here, just pumping backwards. So now we have a clogged nebulizer. Whether it's crystallizing out inside there, just coating it enough to block it, whatever it was, we'd have to shut it down, remove our nebulizer, clean it, put it back together, and then start all over with calibration standard number 1. Big waste of time. Our reference standard that we run would constantly fail on us. So we had a lot of problems with this. We do run at 3 degrees C, which may be causing part of this problem. We haven't changed that. We're still running at 3 degrees C with the OptiMist Ion. This is the one that's on our MS. Again, same conversation last year. After we talked about OES, we started talking about this one. So we bought this one as well. And here it is on our system. Since installing that, we have had 0 clogs, 0 restarts. Our reference standard is passing. We haven't had to restart. We have no more backflow issues with the tubing. And again, we don't really touch this. It's on our system. It stays on our system. We change out our tubing. We do not touch the nebulizer. We just let it run up there. We'll run 2% acid through it to clean out. We'll run some True Rinse, I think we have, that kind of cleans out our tubing in our system. But otherwise, this does not leave the system either. The only time it changed was when they came in and did our PM and wanted to put their micro mist back on to do all that, to get their numbers. Otherwise, the OptiMist is on our MS system, and it runs for us constantly. We run this 3-4 times a week when we're running this material, this campaign, and we've had no issues since. So for us, both the ICP-OES and the MS, we were having issues with the sample types that we run, the crude oils and this catalyst material. And basically the same thing. We were clogging nebulizers is what it turned out to be. So since switching to these nebulizers, we have not had an issue since. Everything is passing, everything is flowing, everything is really clean. The OptiMist XL and Extreme and the Ion, which we have all three, have reduced our face time with the instrument. We now can set it up on our auto samplers and walk away and know that when we come back, especially on the OES, that run can sometimes take 10 to 12 hours. And we just walk away and we come back and we have our data ready to go. And we're able to continue to run both of these with our chilled spray chambers. Both the OES and the MS have a chilled spray chamber on them, and we have no more issues at all. So that's it for me. Thanks, Sergey. Thank you guys for coming. And if there's any questions, I will try and answer them.
For organic analysis and inorganic, like the first set.
I couldn't hear that.
Sorry.
It's okay.
Oh, the first set that you showed, which was without digestion, for that, do you have a separate instrumental setup completely? And then for the inorganic one?
The stuff, the crude oils that we run where we do not digest, they're just diluted, that's run solely on our OES system. And that one pretty much stays in an organic configuration. We run the other stuff on the MS system. So 2 instruments, 2 completely, one set up for aqueous, one set up for organics.
Yeah, and the reason I was asking is with all budget constraints, we are having to consolidate our instruments. So we are being asked to have one instrument. And then what I've heard is it's a lot of trouble if you're trying to switch between organic mode and inorganic mode. So
It's not that difficult, actually. So we have a set spray chamber and a nebulizer for our aqueous that when we pull it off, it goes right into a drawer, tubing, everything right on it. And then we have the organic set up with our cooled spray chamber and the tube and everything set up. Just the most important thing is make sure we run the torch at -1 for the organics. Just remember to put that back up to 0 when you go to aqueous.
just set up change.
Yeah.
Okay. Makes sense.
And the energy will change.
How long does it take you to switch over from aqueous to organics? 5 minutes?
5 minutes.
Okay.
Yep. Everything is programmed into method, right? So as long as you get the hardware on, you pick up the aqueous method or your organic method, and all of your settings there are for gas flows, nebulizer flow, argon flow, plasma, everything is set in the method.
On your organic that you say you dilute with, what do you dilute your organics with?
Toluene.
Toluene? Premisol? Okay.
No, Premisolve does not work for us. We were using Premisolve 10 years ago, and it would dilute about 5% of the crude oils that we would receive. We sent the rest out for analysis. When we went to Toluene with the new system that we bought, when we got the AJ system, we went to Toluene. We now get 100% of our materials into solution.
How has one of the stuff right now on top of my head, but That's the only component when Promisol doesn't work, when it's not soluble, that helps us out. I need to look it up which one we use. But
There was a talk last year, I
It's
forget,
on
and I talked to her and then I didn't hear anything more. She had something that was supposed to be really nice for
I
that.
can provide it to Sergey, and you can all reach out to him and
That would be nice.
give you information.
Thank you, Randy, for the presentation. So, you mentioned the chilled spray chamber. So how do you? What's the difference with we just put the spray chamber in and your chilled spray chamber? You have something to chill the spray chamber?
Yeah, so we run, well, the Scott spray chamber on the MS system is pretty standard, but on our OES we probably don't have to. Toluene's not really that volatile, and neither is our oils, but we do run a chilled spray chamber on that. We were at 5 degrees, we've now bumped that up to 9.
And I think it keeps a consistent mass because any fluctuations in the room will change the mass of the solution. And that may throw your analysis.
Oh, okay.
So it's made to make the mass of that liquid consistent.
Yeah.
Sorry. Are your organics, what kind of detection limits are you?
So I've never really pushed it. I will report a half a ppm or higher, and I'm pretty confident at that number. We've never really tried to go down lower. We will eventually. They're going to ask us at some point to go lower. So, but it also depends on the element, right?
True.
They're going to want the lowest sodium number that we can get, and we're probably already there.
Yeah. Okay. Thank you.
All right, great discussion. Thank you.